Good morning. My name is Fernando Berlinck Dutra. I'm CEO of SmartDry. SmartDry is developing technology to reduce for the reduction of mineral humidities using concentrated solar energy. Humidity in minerals impacts on logistics and processing, and our basic premises were heat up the ore with direct focusing of concentrated solar energy, speed up evaporation, thus humidity reduction. In order to do this, we took into consideration several factors, but most important is to do the minimum possible of operations in mining and port, and be able to do it with the less possible investment in CAPEX and OPEX. So we are developing two solutions for Vale. One is injecting concentrated solar energy into pile forming at courtyards and injecting onto or being transported by conveyor belts. The proof of concept model has 30 kilogram samples and controls of iron ore. The first experiment, the ore falls from a funnel, and as it falls, it hit it by all the concentrated solar energy. The second uses a Fresnel lens to focus and inject the concentrated solar energy. So those are the two challenges. The most important thing to remember is that the size of the target is very big. I know the amount of mineral that is dropping, the humidity and everything else, irradiation and on-site, all the factors are there. So by injecting directly here, what happened is that each and every layer of the pile receives the amount of energy needed to evaporate the water present. Conveyor belts are great because they give you a huge area for harvesting energy, where in some cases courtyards can be cramped, can be difficult. So by injecting on the ore being transported just prior being dumped, I'll be putting also the energy inside the pile as the pile grows. So this is the first experiment, and as you can see, the funnel is here. Here, the sand dropping is dark. Here is very bright because of the sunlight being hitting. You see the shadow here of the funnel. So all this bright luminescence here you see is the concentrated solar energy. On this side here, you see the thermal image. This is a short video that shows the actual working of the funnel. It was a windy day anyway, but we can clearly see here, again, the shadow of the funnel, the dark area of the sand dropping and getting brighter, and all sides of the pile being heated by concentrated solar energy. This is the solution to use for conveyor belts. The idea is that the focal point will be above or below. So the idea here is to ensure that the concentrated solar energy does not hit the belt, the rubber belt, because otherwise it will damage. So the area here will be as big as possible to ensure maximum injection. This is the setup that we are doing with a Fresnel lens with 4 focal points. As you can see here, the concentration of energy is quite significant. But all comes down to the economics. So as an example, taking a bauxite example from 13 to 3%, which means 100 kilograms of water has to be evaporated for every ton, which means 250,000 kilojoules of energy. That translates to 7.1 kilowatts an hour. In Recife area, there is 5.1 average. So it means that I need 14 square meters per ton. Assuming I have 200 days of sun and I want to dry 20,000 tons per day, which will give 4 million tons, I will need 280,000 square meters of heliostats at a cost of $106 per square meter, gives me $29.7 million investment. But the freight from Brazil to China costs Vale between $20 to $40 per ton, which means this 240,000 waters that will be removed will save between $4.8 to $9.6 million per year, giving a ROI of 6.2 to 3.1. So it proves that technology is soundable and I'm really willing to network with any company that is wish to know more about it. Thanks a lot.